This is the second triangle proof review if you chose to do it, or if you just need some more examples. I am going to do every single one of these, so feel free to watch the whole thing or skip ahead to which ones you need to see. But here's the answers for this. So for the first one, the first 3 reasons are given to you, and you just need to make sure that you mark them accordingly. So for this first one, these are sides, and so when you mark a side, you mark them with the tick mark right in the middle of the side. They're both going to get 1 because it's the first side we've marked. The second set is the second set of sides. We're going to double mark those sides. And then the third given is our third set of sides, so we would triple mark those. When you get done, we have marked 3 sides, so this would be side, side, side. For the next one, the first 3 statements were given, so we're just going to write given. And then again, we're going to go through and mark. So this first one is a set of sides, GI and ML. So we're going to mark them with 1 mark each. The second statement are actually angles this time. So we're going to mark these angles with an arc mark. So angle I and angle L. And then our third statement is another set of sides. So second set of sides mean we double mark. So IH gets a double mark and LK gets a double mark. So now we've marked 2 sides and the angle right in between them. So this is side, angle, side. For the third proof, the first 2 statements were given. So we will start by marking those. The first one is a set of sides. Again, we're going to mark side BC with 1 tick mark directly in the center, and same thing with DC. The second statement is also sides, so we're double marking this time. So AC is right here, and EC is here. After we run out of givens, we either look for a side that they share or vertical angles. So this one has vertical angles. You'll notice that they're named BCA. Notice that C is that middle letter because it's the vertex. And the second one is DCE. Again, C is the middle letter because it's the vertex. So this is the vertical angle theorem. And now when you look at your diagram, you have 2 sides and the angle in between marked. So this is side, angle, side. For proof 4, the first 2 statements are given. And then to mark those, GH and LJ are sides, so they get a single tick mark in the middle. GJ and LH are sides, so they get a double tick mark right in the middle. And then I'm out of givens, so next I'm looking for a line that the 2 triangles share or vertical angles. I don't have vertical angles, but they do share this line right in the middle. I really don't love how they wrote this. We typically write it the exact same both times, so it should say HJ is congruent to HJ, and we call that reflexive. And then lastly, they say these 2 triangles are congruent because we've marked 3 sides, so that's side, side, side. For proof 5, the first 2 statements are given. In the first statement box, we have AB congruent to FE, and those are sides, so we're just going to mark them with a single tick mark. Next, we have angle A is congruent to angle F. Those get marked with an arc mark on A and F. And then our last given is C is the midpoint of AF. So here's AF, and C's right in the middle. And what that tells us is that this segment gets split into 2 parts that are the exact same length. So here's my 2 parts. Part 1 is called AC. part 2 is called FC. The reason we can mark those congruent is because that's what the definition of midpoint is. It means that point is right in the middle, so those two sections are the exact same length. And we need to make sure we add our double mark to those sides. After that, I've marked two sides and the angle in between. So this is side, angle, side. But we're still not done because then it says, prove that angle B is congruent to angle E. And we know this because corresponding parts of congruent triangles are congruent. For proof 6, the first reason is given, and they've already marked those parallels with the arrows. The part they haven't marked is the statements for number 2. So just in case you forget, you can highlight these parallel lines and the transversal that they touch, and it outlines those angles for you. So here you have JHL, and here you have GLH, and those are alternate interior angles. Put those back. I just wanted to erase so I can highlight the other set for you. And then the second time, if I'm focusing on the double marked parallel sides, again, it outlines it for you. We double mark the second angles, and they're still considered alternate interior angles. After you use your given, we look for vertical angles, which we don't have, or a line that the two triangles share, which we do have. So we have this line HL that they share, so we can mark that. Again, I really don't like how they've written this. We want it to look the exact same both times, and we call that reflexive. Now we can prove these triangles are congruent because we have two angles and the side right in between those angles. So angle, side, angle. And then lastly, HJ is congruent to LG because corresponding parts of congruent triangles are congruent. For proof 7, the first reason is going to be given, and we're going to mark our figures. So AB is congruent to CB. Those are sides. They get a single tick mark. For the second one, BD is perpendicular to AC. And remember, perpendicular tells us that these are right angles that are formed. So then we say angle ADB and CDB are right angles. And that's the definition of the vocab word. So definition of perpendicular. Remember, anytime you have perpendicular, there's two statements back to back. So the first one is definition of perpendicular. After that, you say the right angles are congruent because all right angles are congruent. After that, we're out of given, so you look for vertical angles or a line that they share. These triangles share side BD, so we double mark that and we call it reflexive. And now these two triangles are congruent because if you look, we have the right angle, the side across from that, which is called the hypotenuse, and the leg. So this would be HL. And then again, anytime you prove two triangles are congruent, you can prove any sides or angles are congruent because corresponding parts of congruent triangles are congruent. For the next proof, we have all of our givens are in the first statement, and then we can mark those. So the first one says HG is parallel to KL. So we mark parallel sides with arrows going the same direction. And then the next one says HG is congruent to KL. So that would be a tick mark. Then after that, I need to use that parallel information. So if you highlight your two parallel lines, and then I highlight a side that they both touch, so like this, you can see that two angles get outlined, and they said it's H and it's K. So if I mark those would be considered alternate interior angles. The next thing is I could mark these vertical angles that exist. So here and here, I need to double mark these angles because I already single marked. They named them H, I, G, and K, I, L. Notice that I is the middle letter and it's the vertex. And this is the vertical angle theorem. After that, I have all the marks I need to prove the triangles are congruent. If you look, I have 2 angles marked and 1 side, and the side's not in between, so this is actually angle, angle side. And then after I've proved the triangles are congruent, we know that this angle is congruent to this angle because corresponding parts of congruent triangles are congruent. For this proof number 9, we have the given information in the first box. So given that AB is congruent to DE, so AB and DE both get 1 tick mark. The next given is angle B is congruent to angle E, so I write that here. I write the word given, and then I go mark my figure. So angle B gets an arc mark, and angle E gets an arc mark. The third statement was also a given, and so we write the word given. It's our second side, so we double mark this one. So here's side BC, here's side EF. And then once I get done, I can prove the 2 triangles are congruent. So triangle ABC is congruent to triangle DEF. And if we look at our diagram, we marked 2 sides and an angle. The angle is right in between them, so it's side, angle, side. For proof 10, I can write down my givens. So the first one is GH is congruent to MK, and then I would go mark those sides. So GH gets 1 mark and MK gets 1 mark. My second given, angle H, is congruent to angle K, so I write that down. I write the word given, and then I go mark those angles. So angle H and angle K. For the third given, I have angle L is congruent to angle I. Since this is the second angle I'm marking, I have to double mark the angle. So angle L and angle I. And then I can prove the 2 triangles are congruent, and if I look, I've marked 2 angles and 1 side. So remember, I am deciding between angle, angle, side, or angle, side, angle. And the easiest way to kind of talk yourself through it is, here's the 2 angles. Is the side right in between? And the answer is no. So it's not angle, side, angle. It's angle, angle, side. For this next set, I'm going to start off by filling in my given. So I have BA is congruent to DE. I'm going to mark those with a single tick mark. The second statement, angle BAE is congruent to angle DEA. That's also given. Remember, you're always marking that middle letter, so kind of imagine to yourself you're outlining it, BAE. You can see how the corner of that angle is right here. So then same thing, DEA, kind of imagine it in your head, DEA, so here's where you would mark. After that, I've used all my givens, so I look for either a side the triangle share or vertical angles, and I don't have vertical angles, but these triangles do share side AE. So AE is congruent to AE. We call that reflexive. This is a side, so we double mark. And then after that, we can prove that triangle ABE is congruent to triangle EDA. And if you look, I marked 2 sides and the angle right in between them. So this is side, angle, side. For the next proof, I have angle G is congruent to angle L. that's given. So I can mark G and I can mark L. The second given is GK is congruent to LK. So GK congruent to LK. This is also given. This time I'm marking sides. So here's GK, here's LK. I'm out of givens, so I'm either looking for vertical angles or a line they both share, and in this one I have vertical angles. Since this is my second angle, I'm double marking it. Then we have to name these. We know K has to be the middle letter because it's the vertex, so maybe I'll call my first one G, K, J. When I follow that pattern, the second one's going to be named LKH. Make sure you include your angle symbol. And we call those vertical angles, so we'll write vertical angle theorem. After that, I've marked 2 angles and 1 side. So here are my options. It's either angle, angle side, or angle side angle. So here's my 2 angles. If you look, I marked the side directly in between them. So that makes this angle side angle. For this next one, I'm going to start off with my givens. So AB is congruent to DE. This is given. And I'm marking those with 1 tick mark. So here's AB and here's DE. My second given, angle A is congruent to angle D. Those are angles, so I'm marking with the arc mark in the corner of the angle. After that, I'm out of givens, so next I would move on to my vertical angles. So I double mark those angles, and then I have to name them. I have to name them with 3 letters, and C has to be that middle letter, so maybe I would call the first angle BCA, and then I could call the second angle ECD. After that, I've proved the triangles are congruent, so I can name the first triangle however I want. I'm going to call it CAB. And then I just need to follow that pattern. So if you look, CA is going from the double angle to the single. So CD and then E. And we have proved these are congruent because we've marked 2 sides and 1 angle. So, 2 angles and 1 side. So it's either angle, angle side, or angle, side, angle. If you look, if it were the side in between the 2 angles, your mark would be right here. There's not a mark, so this is angle, angle, side. Once we prove the triangles are congruent, we know that angle B is congruent to angle E because corresponding parts of congruent triangles are congruent. For the next proof, they've marked your first given on the diagram for you. So they've marked both sets of those parallel lines. Remember, whenever we have parallel lines, we can use angle pairs. And so right here, if I outline these parallel lines and this transversal, you can see that I have alternate interior angles. I can do the same thing with this second set, and it just gives me a second different set of alternate interior angles. Remember when you double mark your second angles, so don't forget to do that. So my first set, the yellow set, are going to be H, G, K, and L, K, G. My second set would be the green ones, so L, G, K, and H, K, G. And these are alternate interior angles. After that, you've used your givens, so we can mark this line that's reflexive, which would be GK. So GK is congruent to GK, And once I look, I have two angles and the side right in between them. After you prove that the triangles are congruent, we can now prove that angle H is congruent to angle L because corresponding parts of congruent triangles are congruent. For the next one, we have some given information. I'm going to mark it in red. So DC is congruent to BA. And then it says angle C and angle A are right angles. Remember, you mark right angles with the square. It has to be very specific. Now that I know they're right angles, I can also say angle C is congruent to angle A because all right angles are congruent. And now that I'm looking at this proof, I guess they didn't want you to do that because I'm about to run out of boxes. So I'm going to erase this. If you added it, it would be great. If you didn't, it wouldn't be marked wrong. So I'm actually going to get rid of that so I have room to finish everything they need me to finish. So then I also know that DB is congruent to DB because it's reflexive. I double mark it because it's my second side. And now I have enough information to prove these triangles are congruent. So if I call this bottom triangle, which I'm going to highlight in yellow, if I call it DBC, in order to make everything line up, I would have to call the second triangle BDA. And these are congruent because I have this right angle. I have the side across from it, which is called the hypotenuse, and I have one other side marked, which is called a leg. So this is HL. After you've proved your triangles are congruent, we can prove CB is congruent to AD because corresponding parts of congruent triangles are congruent. And finally, 16. So all of the given information is going to go in this first box. I'm definitely going to run out of room if I write it, so I'm kind of just going to do this. So all of this should be written right here. They have already marked the parallels for you. They have not marked your definition of, your midpoint part, but I'm going to leave that for just a second. So the first thing they do is they tell you that G and angle LIK are congruent. How they figure this out is they're using those parallel lines. So if you look here, these are parallel, and then you have this transversal. So those angles are actually corresponding angles. If you're having a hard time recognizing it, let me just draw you a quick sketch up here. Maybe that makes it more familiar for you, and then see how I could complete those triangles. So they are corresponding. And then the second set of angles they list, angle K and angle HIG, they're also corresponding. They just use that second set of parallel lines. So again, if I just outline, it kind of outlines it for you. Those are also corresponding angles. After that, I'm going to use this midpoint information, which I haven't used yet. So it says I is the midpoint of GK. So down here is GK. So focus right here. GK gets split into two pieces that are the exact same length because I is right in the middle. So the two pieces are called GI and KI. And so that's what we're going to mark. So GI is congruent to KI, and that's the definition of midpoint. After that, we can prove our triangles are congruent. So you can name the first triangle whatever you want. I'm going to call it GIH, and then we just have to make sure our marks match up. So I went from G to I, and then I to H. To make things match, I would have to call this one IKL. And these are congruent because I have two angles and the side right in between those two angles. After I've proved the triangles are congruent, I can prove that angle H is congruent to angle L because corresponding parts of congruent triangles are congruent.